Today we're going to talk about parallel and perpendicular lines, what that looks like for their equations and what that looks like for their slope. So if we graph these two equations, we have y equals 3x plus 4. 3 is our slope and 4 is our y-intercept. So we can go up 4, there's our y-intercept, and then remember to graph, we can either go up 3 and to the right 1, or we can go down 3 and to the left 1. Remember, if we don't have enough space, we can go the opposite direction. And then we're going to connect those dots and make a nice line. That's the graph of our equation, y equals 3x plus 4. Has a y-intercept of 4 and a slope of 3. So let's look at our next equation. We have a slope of 3 again, and our y-intercept this time is at -2. So this time we're going to go down 2, and then we're going to go up 3 over 1, up 3 over 1, to graph our line. It's going to look something like that. So what do you notice about our lines? You might notice that they don't touch. They're not going to cross. They are parallel lines. And what do you notice about the slope? Well, the slope of our first graph is 3, and the slope of our second one is 3. So we can deduce that parallel lines will always have the same slope. So if two lines have the same slope, they are parallel, and if they are parallel, they have the same slope, so it goes both directions. Okay, here we have two different equations. They are also in slope-intercept form. We have y equals 2x plus 3, so we're going to go up 1, 2, 3. We're going to go up 2 over 1, or we can also go down 2 over 1 to graph our line. So here's our line for our first equation. We have y equals 2x plus 3. Our second equation is also in slope-intercept form. Notice that our slope this time is negative. So as we are going to the right, our line should be decreasing. And our y-intercept is at 1, so we're going to put a 1 there. Our rise is -1. Our run is 2. So we're going to go down 1 over 2, down 1 over 2, down 1 over 2. And that gives us our second equation. So what do you notice about these two lines? Well, I don't know if you notice exactly, but this is a right angle, so they are perpendicular lines. So we know that when we have perpendicular lines, have the opposite reciprocal slope. In other words, you notice our slope was 2 for our first equation, and our slope was -1/2 for our second equation. Remember, the reciprocal is where you flip your fraction. And the opposite reciprocal, that tells us we're taking the opposite sign. You can check this by multiplying your slopes. So the slope of one times the slope of the other should give you -1. So if we check this, the slope is 2 times -1/2. 2 times -1/2 is -2/2, which is -1. So when we're looking for a pair of perpendicular lines, or looking at a pair of lines, we can multiply their slope. If their slope is equal to -1, then that is a perpendicular line.